Hello class and welcome to lesson 3.10 counting subsets. So today we're going to learn different ways of dealing with combinations where the number of items you select are not fixed. Okay, so you're going to see the word of sum or at least one being used. Okay, so let's take a look at an example. First of all, folks, if you're not sure what this is, it's Fraggle Rock. It was a cartoon when I was about 7 or 8 that was on. If you're not sure or familiar with it, just Google it on YouTube and it'll show you the intro of it. These are little characters that lived under the ground anyway. So here's the example. The Fraggle Rock fan club has 8 members. Okay. How many committees of any number of members, and that's where that R is not fixed, are possible? So what do we know? We know N equals 8 because we have a total of 8 members. But for R, normally R we say we want 4 members or we want 3 members. But R is not fixed. So you have to take a look at each case. Okay? So let's do that. You're going to need a little bit of room here, so make sure you're writing small as you go from left to right. Because you could have, to make a committee, you could have 0 members, okay? Or you could have 1 member. Okay, I'm not going to keep writing member over. Or you could have 2, or 3, or 4, or 5, or 6, or 7, or 8. All 8 could be in the group. Okay? All right. So let's take a look at how we would do that. If we had 0 members out of the 8, it's going to be 8 choose 0. And or means to add. Okay? And then you would say 1 member, we take the 8 and we choose 1 plus. If we had 2 members, 8 choose 2 plus 8 choose 3 plus 8 choose 4 plus 8 choose 5 plus 8 choose 6 plus 8 choose 7 plus 8 choose 8. Where all 8 members are in there, right? All right, so you can use a couple things here. But I would just either use your calculator or you could take a look on your Pascal's triangle to help you with this as well. So it's going to be 1 and then plus 8 plus 28 plus 56 plus 70 plus 56 plus 28 plus 8 plus 1. Okay, so you again could just use your calculator, or don't forget this is the same as the 8th row in Pascal's triangle. Okay, all right, so adding this up, folks, plug in your calculator. It's going to equal a sum of 256, but just remember that that includes a committee. I'll use committee for short form, COM, with 0 members. Okay? Because sometimes it says you must have at least 1 person in the group, but it has 0 members. Okay? And folks, ironically, if you remember the sum of the rule of sums for the Pascal's triangle, check it out. 2 to what power equals 256? And remember, you had a homework question on that already. X equals 8. Okay, so it's the 8th row, and 8 sums up to that. This is going to lead, that little shortcut is going to lead me into another way of looking at how to count this. Because this, ladies and gentlemen, this is a big equation here that we wrote down right here. Big equation. Let's take a look at it another way to count this. We're at the same answer, but a lot less work, actually. So another way to conduct it would be to consider each member individually. So each person could be selected or not. So you either get picked or not. So if we take a look, we deal with person 1. Okay. And we have to consider person 2 and 3 and 4 and 5 and 6 and 7 and 8. And each person has either a choice to be selected or not. Okay? So, two options for so person 1 could say, yes, I'm in. No, I'm not. Two options. Same with person 2. Same with person 3 and 4 and 5 and 6 and 7 and 8. What do you notice here about this pattern, which reminds us of the sum of the Pascal's triangle, is 2 to the power of 8. Okay, and just remember that 8 represents the number of people. Okay, whereas the 2 is the number of choices per person. And that's either I'm yes in or I'm not in. Okay. All right, and plug that into your calculator, 2 to the power of 8, that's 256, and includes what we call, you might remember this, the null set. Okay, and remember from when we did set notation, folks, that's the null, so where nobody's in the group, or it's a group of 0, okay? So the null set means 0 people. That's not, yeah, 0. Maybe I'll write it out instead of people thinking open. So, no body in a group. Okay? Nobody. Okay? Or 0 people in the group. Awesome. So that leads us to a nice formula that relates to Pascal's triangle. That's why I wanted you to just spend that time doing it a couple classes or lessons ago. Okay? So in general, a subset has n distinct elements. Okay? And this means no repeats. I'm going to deal with that a little later. Okay? Okay? And has the following formula. So 2 to the n, which is the same as the sum of the Pascal's triangles rows, okay, including the null set. However, if it says you can't have a null set or a non-empty subset, you just take the equation and subtract 1 from it. So on your unit test, if it doesn't specify, I would give both answers on a test. And then you can just specify it's this answer with a 0 with a null set, or subtract 1 and go 1 less. Okay. All right. So remember that this phrasing would also be if you have to have at least one person in the group or whatever. So if you see at least 1, then you're going to be using this formula here. Okay? All right, that's key wording for that. Okay, and just remember that you might want to write down beside this formula that R is not fixed. Okay, so the number you're selecting is not fixed. All right. So Miss Corey at our school deals with United Way, and she's really good at chairing that up. And she asks you to make a donation to United Way. And in your wallet or purse, you have a $5 bill, a $10 bill, a loonie, and a toonie. How many donations could you make? Okay. Well, let's take a look. We have A, which is 1 of each. So how many items? How many separate items do we have? We have 4 separate items. Okay, so we have 4 items, which is the 5, the 10, the loonie, the toonie, right? So how many possible ways could you do it? Each item you could donate or not, so there's a 2 choice for that, per bill or per money amount. And how many separate items do we have? We have 4 distinct items. So plug that in your calculator. We have 16 possible donation. Okay, and that's including a no donation, right? Okay, perfect. All right, so now we're going to thicken the pot a little bit, guys, but notice these were separate or distinct items, okay, and there was no repeats. Now we're going to take a look at an example where we have repeats, okay? All right. So notice the $5 bill, it's distinct, it's by itself. We've got the $10 bill by itself. But notice this is not distinct. We've got repeats. So we've got a repeat here. Okay? And same with the 20. There's a repeat here. So you have to deal with that a little different. And don't worry, I'm going to give you a formula after this. Okay? So to figure out the number of ways here, okay, it's easier when you've got a distinct item. So for the $5 bill, you could put it in or not. So that's two options. Times, same with the $10 bill, you could choose to donate it or not. Okay, now here's the tricky part. If you have 3 loonies, okay, how many different possible ways could you donate that? Well, hey, you could donate none of them. You could donate one of them, you could donate 2 of them, or you could donate all 3 of them. So how many different ways are there to do that? There's 4 ways. Okay? All right, or 4 different choices. Okay? Likewise with the $20 bill. You could either donate none of them, 1 of them, or 2 of them. So really, when you have a repeat, you're adding 1 to them. Okay, have you noticed that? Okay, distinct items, you don't have to worry about it. Well, really, you got 1 bill, you got 2 options, right? You've got 3 coins, you have 4 options. So you're really adding 1 when you have a repeat, or even if you don't have a repeat, because you can donate it or not. So let's plug that in our calculator, folks. So 2 times 2 times 4 times 3, that gives you 48 possible donations. Okay, and that includes null set, which means no donation. Okay, all right. If you're saying this on a test and you wanted to include both, you could say or 47 with a donation, meaning someone has to give you something, right? You have to give you at least 1 item. Okay? Alrighty, so here's the formula, folks, when we have some repeats. Okay, so when counting subsets of a given set with different items, P, Q, and R, and they're identical items, the number of subsets is this formula right here. Okay, so this is when you've got repeats. So please put in repeats. Okay. Awesome. Let's do a couple more examples on the last page and then we will be done. Okay. Moving on. Caitlin has 4 Barbies, 1 Tonka truck, 2 stuffed toys, and 3 Dora books. How many ways can Caitlin choose 1 or more of the toys? So if it says 1 or more, that tells me that you can't have the null set, right? So that means you're going to have to subtract 1 when you're done. Okay? All right. So let's figure out how we have this. So if there's no restrictions, we're going to say Barbies. So we're going to go Barbies times the Tonka truck times the stuffed toy, so ST, times the Dora books, DB. But I'm also going to take it and I'm going to subtract 1 because, folks, we can't have the null set, so we're going to subtract the 1. Okay, so how many different ways? So we've got 4 Barbies, so if you take 4 plus 1, that's really going to be 5, right? Times the Tonka, you have one Tonka truck, either you donate it or not, or choose it or not, so that's 2 possible ways. The stuffed toys, there's 2 of them, so add 1 becomes 3. The Dora books, there are 3 of them, so add 1 becomes 4. But don't forget to subtract 1 because we can't have a null set because it says she has to choose 1 or more toys. Okay. All right, plugging them in. So if you calculate it without the null set, folks, you would get 120. But if you subtract 1, it's 119 because it's a word problem. We're going to say, therefore, Caitlin has 119 choices for show and tell. She can't show and tell without bringing anything in because she's got to choose at least one thing. Be crazy if she brought everything in, but that's fine. Okay, now here is a little bit of a restriction. Okay. Caitlin insists on bringing one or more Barbies. Okay. So if we know she's bringing one or more Barbies, we don't have to worry about the null set because she's bringing at least one. Okay. So if she's bringing at one or more, that means out of the 5, she's bringing at least one. So 1 for sure is taken out. So out of the 5, 1, 2, 3, 4, 5. 1 for sure she's bringing. So we know that. So instead of having 5 to choose from, she's only choosing from 4 Barbies. Okay? So there's 4 options there. So it's 4 times, she still has 2 for the Tonka, she still has 3 for the Dora, sorry, for the stuffed toys, and she still has 4 for the Dora books, but we're not going to worry about subtracting 1. Okay? All right. And adding that up, she's got 96 choices. Okay? And you don't subtract 1 because she is bringing at least 1 Barbie. All right, so hopefully that's a cool introduction to how you deal with subsets and 2 different methods you can take a look at dealing with combinations and how we've gone to the subset formula. And don't forget, folks, with your general formulas 2 to the n or 2 to the n minus 1, you can use the Pascal's triangle for this one. Okay, find your total, and then if it's the null set, then subtract 1. Just make sure when I do the subtract 1 goes, it's 2 to the n, and then subtract 1. Make that look a little better. So the negative 1 isn't part of the exponent like it looked. Awesome. Here's your homework, guys. Page 286, numbers 1 to 5, 7, 8, 10, 13. Have a great day.